All right, so one-sided limits and limits at infinity. So in addition to examining the limit as x approaches c, as we've discussed one-sided limits and limits at infinity previously. So L'Hopital's rule is valid in these cases also. So, we've looked at them before, but we can also use L'Hopital's rule. And so what we have here is we have evaluating limit as x approaches 1 from the left side of ln of x over x minus 1, the quantity squared. All right, so what is as we approach 1 from the left? Well, that's going to approach 0 here because if you think about if it's equal to 1, it's going to be 0. And if we put 1 in here, we're going to have 0 there as well. So what we can do now is we can take the derivatives of the numerator and the denominator and see what we get there. Well, the derivative of ln of x, remember, is 1 over x. The derivative of this is going to be 2 times x minus 1 to the 1, or just 2 at the x minus 1. And then we have the derivative of x, which is 1. All right, so let's rewrite this. Let's put the x down here. So that gives us 1 over 2 times 1 is with 2, and then times x minus 1. And so again, we're going to 1 from the left. Well, if we think about that, that could be a 1, so that would be 2. But if we go to put a 1 here, that's going to be a 0. And so guess what? We're going to end up with 1 over 0, and that's not going to work. So we're going to have to use the graph technique again. Okay, so we're going to compare to, well, this is kind of similar to 1 over x, but it's been shifted to the right. Okay, and again, if you remember your 1 over x, what did it look like? It was something like this and something like this. And we're just shifting it to the right. So now we're kind of at, over here, we're something like that. And we're now kind of something like that. And so we're going to x from the left as we're going to the 1 from the left. So that means we're coming this direction. And so that means we're going down to negative infinity. And so our limit then is negative infinity. Okay, so again, we might not have gotten an answer directly because of this, but we get to a point where then we can say, oh, well, we can look at the graph, and as we approach 1 from the left, we're going to that negative infinity. Okay, let's try another one. All right, so here we have the limit as x approaches negative infinity of ln of 1 plus 2e to the x over e to the x. Well, if we plug in a negative infinity, guess what? We're going to have to think about what does that look like as far as our graph goes and the e to the x's and stuff. And so e to the negative infinity, or e to the negative x, I should say, it looks something like that. So then we have to plug that in. Well, if we plug that in, it's going to give us 1, and then it's going to be, that's going to go to that. So it's going to be a 0 over 0, basically. It looks like when we do that. So we're going to get, again, an indeterminate form. All right, so that means we have to take derivatives. So limit as x approaches a negative infinity. Now the limit of, or the derivative of this is going to give us 1 over 1 plus 2e to the x. But that gives us that. Now we have to take the derivative of the inside. The derivative of the inside is going to be what? Well, that's going to be a 2 times e to the x. Now that's just going to be that, and we don't have to go any further. So we're done with the top part. Now that's all over what? The derivative of e to the x is e to the x. Okay. So now the nice thing is it looks like this e to the x cancels this e to the x, and then we get, uh, my screen is not showing here. Here we go. There we go. All right, so then we get what? We get 2 over 1 plus 2e to the x. All right, so if we plug in our negative infinity now, all right, e to the negative infinity is going to be what as we do that? Well, as we go to negative infinity, we're going to get basically 1 plus 0, because it's going to 0 out here when we do that. And so we're going to get basically 2 over 1 plus 0, which is going to be 1. 2 divided by 1 is 2. And that would be our answer. And again, we had to use our graph to figure out what that limit is going to that negative infinity. And when we plug it in, originally our graph now we have e to the x. So now as we go to negative infinity, we have that. But the reason why I showed what it was, if we plugged in negative infinity, I wanted to see what it looked like at that point. But now if we plug it in here, going to negative infinity, we go to 0. And so that would be what that would be. Okay. All right. So probably confused you there, but hopefully not too much. All right. So let's stop there and we'll come back for more.